Okay, cool. So, yeah, basically, why are we here? We're here to discuss NFRs and their dependencies. If you think that I'm going to go really deep into Spryker, so probably, probably I will not fulfill your kind of thoughts because this is not exactly how it's going to be. I will talk in general about NFRs. We will talk what are NFRs, what are not NFRs, what NFR means, and like general kind of, I would call it a scientific discovery, let's put it that way. And then we slightly go into Spryker projects, but this is something, it's just kind of as a side note. So let me start after I lowered down your expectations. Yeah, I will talk about what NFR means. So a plan for today, we're going to talk basically introduction. I'm going to slightly talk about myself, just teeny tiny. Then we're going to talk about what are NFRs and basically non-functional requirements and quality attributes, how NFRs and quality attributes are different, and actually we're going to check the real examples, teeny tiny, but still we're gonna touch it slightly, and then we're going to talk about Spryker projects. And do you need to think about NFRs, quality attributes, and what you might do on basically your projects, what Spryker provides for you, and then basically recap and Q&A session. So let's get started. That's actually my picture. My name is Helen, or original name is Olena. So you can use whatever you prefer. I'm fine with both names, and I'm a senior solution architect at Spryker. Actually, I think in the next months I'm gonna reach 6 years in Spryker. So I saw how Spryker evolved during the years, and I saw how core was built. I actually built some parts in the core. I touched ecosystem, and now I'm mostly working in solution architecture, so mostly with customers, mostly with projects. But I have a background of the course, so I know how it's working behind the scenes. Apart from that, we prepared basically the certification and training for solution architects as well. And this is something that you heard just in the session before. So if you have any questions or any comments, please like share them somehow with us. You can reach me on LinkedIn or in the forum, just share it with the Academy team, whatever you want. So if you have any feedback, just drop us a message so we have that feedback, because without your feedback, we cannot get better. So we need your input here. Apart from that, what are NFRs and quality attributes? So before we start to talk about non-functional requirements, probably we need to start to talk about functional requirements. What are those? Functional requirements, it's actually the behavior, how the system, the behavior of the specific functionality. So for example, I will give you an example later. And non-functional requirements, it's about the specifics of this behavior. In quality attributes, it's basically the characteristics of non-functional requirements. I understand that it might be slightly hard, so that's why I would like to talk on the examples exactly. So functional requirements, it's what systems should do. For example, as a customer, I want to have a big red add to cart button on my product detail page, and this will be the functional requirement. Yeah, so what that button should do, like what that system should do. Non-functional requirement, on the other side, should describe how that specific requirement has to work. For example, for that add to cart button, I want it to perform in less than a second. So that will be non-functional requirement, yeah, because it describes how the system should work. And the quality attribute for it will be performance. Or this button has to be easily customizable in the future by the new development team. And this is the non-functional requirement. The quality attribute for it is going to be supportability. The next one can be this website in general has to be available 24/7, even on Black Friday. So in that case, we're talking about quality attributes, availability, and probably scalability as well. Or all entered data has to be stored in a secure way, quality attribute security. By the way, I didn't mention it before, but if you have any questions, please raise your hand right away so we talk about it. So if you do not understand something, or it's too fast or whatever, just react somehow so I know and we can get back to it right away. Cool, thank you. So yeah, please don't wait till the end. So list of quality attributes. as you see here, it's huge. And here I just reached level E and I didn't even go further. So in the IT industry, you have a lot of quality attributes. What does it mean for us? Do we need to know all of them? Do we need to comply to all of them on our project? Probably know all of them might be good for you, especially as an architect. But comply, this is actually a really good question, because this is one of the hardest topics probably for solution architects or for an architect in general, to define which of the quality attributes are required for your project. In the industry, you have specific I don't know, like requirements. So for example, in ISO, there is already defined the product quality attribute model. So here we have a specific quality attributes like functional, sustainability, performance, compatibility, usability, security, portability, whatever. And inside you have even more description of what exactly it means for the system. So this is just one of the models that you can use. What is important? Important to know the quality attributes, and important to understand which quality attributes are important. As a start, you can take this model or any other model you find or is needed for you. But basically, for your specific project, you can define whatever attributes are needed. So let's move forward. How actually quality attributes or non-functional requirements are connected? I had an idea that they are connected for sure. I have a bulb here. Yeah, that's basically an idea. And I wanted to check if that's true or not. Does it mean if we are trying to increase some specific quality attribute, we are decreasing others? And that was actually my idea, and I wanted to check it out. To check it out, I wanted to make it kind of in gamification way. So I created kind of rules. It's pretty similar to scientific research. So it has to be measurable, testable, and reproducible. So whatever I'm going to check here, you should have an ability to go back home and to do exactly the same and basically measure it. And you should have exactly the same results. So that's basically where my rules that I defined for this specific game. And plan of attack that I defined for myself is define exact quality attributes to compare. For this exercise, I wanted to compare only extensibility and maintainability, so only these two. Done, defined. Then I wanted to define how to measure them, because as we defined before, the rules of my game have to be, it has to be measurable. Yeah. Then basically we will check how to measure that per quality attribute, define the specific example, and then basically measure that example and compare the results. And we will have kind of some result. So that's plan of attack. Let's move on. So for example, I have a customer who's coming to me. He's an owner, he or she is an owner of the restaurant, and they have a simple menu like pizza, pasta, coffee. Here I have some pictures. Actually, I cooked that by myself. So you can see, probably those are not the best pictures, but still they were super delicious. Anyway, the owner sees that there are more and more people coming to the restaurant and asking for a tea. The owner has, of course, a website, and on that website, they have a super simple class, which is menu with quite a simple function, get menu. And here we're rendering actually three menu items, which is pizza, pasta, and coffee. And this is how we're using basically this class was this function. That's how we render the menu somewhere, somehow. We do not care about that. So now we need to add here, apart from the coffee, tea. So is this specific code extensible or not? Before answering that question, probably we need to understand what extensibility is. Extensibility is basically a measure or like ability of the system to be extensible. Extensible means that we can add some new functionality or some new features without changing the existing system functionality. So we should not touch the existing system functionality. We should just have the ability to add new. And basically the picture that we have here is quite good, I believe, for extensibility. So we should not touch the blocks that we already have, but we should add the new functionality without touching the blocks. That's basically it. So how we can measure the extensibility? So there is no existing formula to measure extensibility, but I want my results to be measurable somehow. So for this game, I defined that one extension point where I can add, edit, or remove some possibilities equals one extensibility point. If we have one extension point, but only with one possibilities, or add, or edit, or remove, then it's going to be basically one divided to all of the possibilities that we have. We have 3, so one extension point with one possibilities is going to be 0.33 extension point. So let's move on. In the example that we had before, now we want to add a new menu item, which is going to be ET. Here, I want to ask you a question. Do you think this code is extensible or not? If you want to, you can raise your hand, or you can write something in the channel. I will give you around 5 seconds. Okay, we don't have people who want to participate to this. Then I will. Yes, thank you, Robert. Only one place that has to be changed. That's the point, that extensibility, when we're talking about extensibility, we should not change the existing functionality. In this specific case, we changed, exactly as you said, in one place, which means that this specific example is not really extensible. Yeah, because we touched the existing system, we touched the existing function. So we can say that this specific example has 0 extensibility points. Then let's check other examples. So for example, we had some kind of refactoring in our system, and we slightly refactored our menu class. Now we have the protected array menu. We have a public function which we can use to add basically menu items to our menu. And then we have another function to kind of get the menu. And then what we're doing, we're creating an object with menu refactored. We're adding menu item pizza, pasta, coffee, and then we're getting the menu. We do not care where exactly we do this right now. We think that, I mean, front end does not matter right now. Then let's add the new menu item here. So when we're adding a new menu item here, we're not actually changing the existing system, but we only kind of adding new item to already existing class, but we do not touch the menu refactored class at all. So we can say that this specific class is extensible, and it has one actual extensibility point, which is this add menu item. With this add menu item, we can or not add anything at all, or yeah, just we can actually add everything that we need here. So that's why the extensibility point here will be 1. Then, because we wanted to compare our extensibility with maintainability, now we need to understand what maintainability is. Maintainability is basically how the code can be maintained during the time. So we're not talking here about adding new functionality. We're talking about supporting the functionality that is there. For example, refactoring or bug fixing or something like that. How to measure? So with maintainability, it's slightly different than with extensibility, because there are some metrics that are kind of standard in the in IT. So for that, we have Hallstatt complexity. Sorry for my pronunciation. We have cyclomatic complexity, and we have code maintainability index. Does it mean that those 3 metrics can measure everything, and now we can say that system is maintainable or not? Actually, not really, because even if we go back to ISO, if we check here the maintainability, we have under maintainability, for example, modularity. Yeah, modularity is not going to be measured by any of this measurement. So actually, we're using only a subset of maintainability here. But even with comparing the subsets of quality attributes, it already will give us some numbers. So I still would like to proceed here. And let's try the first one. Let's try the Hallstatt complexity. Halberstadt complexity is basically several formulas. So behind the scenes, you will have several formulas that can calculate you difficulty, that will calculate you time required to program and number of delivered bugs. Of course, it's formulas that were invented in 1977. They're still used. If you can apply this on your project or not, this is already up to you. So this is your decision. I wanted to check it out. Actually, I wanted to move deeper into these metrics and understand how they work and understand how my changes in the code actually change the results of the metrics. So let's calculate only difficulty, because for us, difficulty in Halberstadt complexity will actually make sense. Yeah, if the difficulty will increase, then probably we're doing something wrong. If the difficulty can remain the same or decrease, then we're good. So for difficulty measures, basically a real kind of related or relational difficulty of the program to write or understand. That's exactly what we're saying when we're talking about maintainability. This is actually the formula that we have. The result of this difficulty formula can be from 0.5 to eternity, and then as bigger the result, the higher is difficulty. For this formula, what we have in N1 and small 1, it's the number of distinct operators, and 2, the number of distinct operands, and 1, total number of operators, and 2, total number of operands. I'm just sharing this with you. Let's move on and let's check what we have in our first example. So to calculate difficulty, we need to calculate N1, N big 2, and N small 2. Here we have number of distinct operators, return array equals new, and this sign, I forgot the name of it. It's basically we have them 5. Number of distinct operators, we have here only menu object and menu, it's actually 2. Then total number of operators, we have 6. Here we had 5, it's kind of unique, and 6, it's total. Why we have more operators than unique? Because we used equals here twice. And then the total numbers of operands, it's actually 3. So we used a menu object twice here. I will not go that deep in each and every calculation. This is just, to warm up, start a bit to understand how we calculate it. And basically, if we calculate everything, we're getting the Halberstadt complexity difficulty 3.75. Let's move on and let's check the second example. The same formula, but different, of course, results. The number of distinct operators still 5. Number of operands is different because we introduced a menu item, this, and basically menu. We used it twice. And the total number of operators, because we are using menu and menu object several times. Here we have 12. But what it means for us, if we put everything in the formula, we still have 3.75. What it means that according to Halberstadt complexity, the difficulty did not change at all. So I was thinking, okay, probably I'm wrong, but it's not that easy for me to stop. So let's move on and let's check what we have. So we have 2 examples. First one, extension points 0, Halberstadt complexity 375. Extension points in second example, extension points 1, Halberstadt complexity 375. It means we increased extensibility, but maintainability remained the same. Okay, let's move on. Let's check the cyclomatic complexity. Cyclomatic complexity is basically when we're creating the graph that is kind of defining the possible states of your code. And then we're calculating the cyclomatic complexity based on this specific formula that we have here, where E is number of edges on the graph, number of nodes, and number of connected components. But basically, we need to think about it as amount of states that we have in the system, and then the transitions among them. On the right side of the slide, you can see actually, those are the states and transitions. It's pretty similar to state machine. Probably we will not touch state machine here, but this is how we calculate it. So for this specific example, if we calculate the edges on the graph, the node, and then connected components, here we have the cyclomatic complexity 3. Of course, you have tools for that. So why I'm doing this manually, just to understand how everything works behind the scenes, double check the tooling, and just do not rely on the tooling, because I really want to understand how it works. But in your case, of course, please use the tool and don't do everything that I did. So cyclomatic complexity for the first example. We actually do not have any nodes. We do not have different states. We have only one state. Yeah. To have different states in the code, you need to have at least some kind of if, else, or something like that. Here we don't have anything. Yeah. If we calculate a graph, we don't have actually a graph. We have only one node, and that's it. Yeah. So the cyclomatic complexity here is 1. What about the second example? It's exactly the same. We didn't change anything. We didn't add any if else or any other constructions. So the cyclomatic complexity still here is 1. What does it mean for us? If we're going back to comparison, we have extension points 0, 0, Hallstatt complexity 375, cyclomatic complexity 1. And then in the second example, we only increased the extensibility with increasing the extension points, but everything else remained the same. Okay, so let's check the third one, because still I'm unstoppable with my research. The third one is code maintainability index. Code maintainability index is slightly more complex than everything we saw so far. Oh, why? Because actually it takes into the account and Hallstatt volume. Hallstatt volume is part of the calculation that is used for, if I'm not mistaken, time and amount of bugs as well. Then we're taking cyclomatic complexity, and here, apart from what we have, we're taking additional lines of code. So now here, lines of code actually matters. What is the problem with maintainability index? First of all, it's not actually considered, at least according to my knowledge so far, as really a standard in IT. And the formula is not stable. What does it mean? It means that for example, Microsoft updated the original formula that was created and kind of changed it. Yeah, changed them slightly, but still, like, yeah, if I'm getting like number 50 in code maintainability, I do not know which formula was used, or even if I know, like, it's just getting a bit more confusing. So, for example, for Microsoft, what they did, they wanted to have values in code maintainability index between 0 and 100. Yeah, so you can explicitly understand where you are. And this is the actually changed formula that they have. They added the max to the formula, and then they added 175 in the end, basically to have this percentage thingy. And then what does it mean for us? As higher value we have, the higher maintainability we have. So kind of higher value is kind of bad. So what is the code maintainability index for this specific part of the code? If you want to, I can share with you the calculations that I did here. But in the end, we got 65.03. I calculated the volume. I calculated the lines of code. Okay, calculation lines of code. It's not that hard. Cyclomatic complexity we already know from the previous example. And yeah, the hardest thing here is basically to apply all the logarithms and yeah, basically calculate what we have. So for this one is the maintainability index is 65.03. And by the way, I use the Microsoft formula. So here the 100 is like the highest value that you can have. Let's check the second one. The second example, here we have 58.83. Why we have such a difference? Actually, because we have the bigger amount of lines in the code. So in this specific case, it actually mattered and it made an influence. So if we're going back to all the results that we got so far, nothing pretty much changed. But here we can see that maintainability index slightly dropped. Yeah, so for this specific example, we can say that extensibility increased and we slightly dropped the maintainability index. But does it mean that increasing extensibility always leads to maintainability? Do you want to react somehow here? So we have some kind of interaction. Hey, I see the reaction. Okay, let's move on. I would say it's hard to make an assumption with only one example. Yeah, so like, probably we need to take several examples more. So let's check more examples. So this is something that we had before. And now what if I, for example, will define the menu already inside the get menu function? So in that specific case, what we have, we decrease the extensibility points, because actually we cannot already remove not pizza, not pasta, not coffee, not tea from this example. Yeah, so we can only add new, but we cannot remove something that is already here. So we kind of dropped slightly the extensibility. But then everything else actually remained the same. Yeah, because we didn't change the amount of operands. Yeah, so that's thingy exactly the same as it was before. Maintainability index exactly the same. And then when we move it out, then basically we're increasing the extensibility, and we have exactly the same values for all other calculations. So what does it mean? We increased extensibility, but maintainability remained exactly the same, but with teeny tiny change. Let's check another example. Now I wanted to go into dirty code because without actually getting into dirty code, it's kind of hard to play around with those values. So now, for example, under add menu item, we have unnecessary if-else construction. So if you really do a nice look into the code, you see that this is not needed here. Yeah, so we can remove if-else. But what if it's there in the code? So we still have extension point 0.33, but cyclomatic complexity here is already 2, which, if we just remove if-else, we will decrease the cyclomatic complexity, and if we move out the add menu item out of the main class, then we increase the extension point as well. So for this specific example, we increased extensibility and we increased maintainability as well. The next dirty code addition is, let me see what we have here. Oh, okay, this is a good example. And now what if we are adding those if-else unnecessary construction? I mean, it's still possible. So it means that and we moved add menu item into the main class. So basically we just reverted the examples. So in that case, we actually decreased the extensibility and decreased the maintainability as well. So does it mean that increasing the extensibility always leads to the decrease in maintainability? Actually, no. But does it mean that quality attributes depends on each other? Maybe, yeah, because as we saw on examples, sometimes they do, sometimes they don't. And this is something that we actually measured, yeah. But does it mean the implementation details matter? Yes. But what actually, sorry, too early. What does it actually give it to me? Like, I don't know, what did I learn today? Yeah, now I have this knowledge that maybe they depend, maybe they're not, and what? This is actually a good question. What does it mean for me? It means that for myself personally, when I start to work on the project, I have to clearly identify what are quality attributes for this specific project, for this specific customer, what is important and what is not for this specific project. Why? Because for some project, for example, maintainability and extensibility will not be needed. What if we're working on the MVP and we know for sure that we're going to use it only, I don't know, for demo presentations for somebody, and then we're gonna take something else? Still possible, yeah. Or let's still go back. Or what if we're talking about B2B case? B2B, when we're talking about business to business. For B2B cases, most cases, the performance is not that critical, at least, yeah, but some other functionalities might be more critical. So it's important to identify what quality attributes are actually required for your specific project. Then during the actual development, I'm trying to analyze all the dependencies among the quality attributes, and if we're developing something new or we're removing some functionality or whatever we do might influence other quality attributes, I will try to notify all the stakeholders and basically everybody who might get involved or who might get harmed by this. And this is something that I do on any phase of the project. It can be pre-sales, sales, it can be development, proof of concept, whatever. If I see that there might be some dependencies, so with increasing the performance, we might decrease some maintainability or vice versa, I will try to notify everybody who can get harmed by this. And then during the project development, I'm trying to keep track of all the decisions that we made. Yeah, so if we made a decision that now performance is more important than everything else, this is the decision that I will write down. I will write down who was on the call or whatever, who reviewed this documentation, basically all the stakeholders that were notified by this and who accepted this, and ideally the date as well. Why? Because what if I am, as a solution architect, getting sick or whatever? Yeah. So what if I'm not there to answer some questions and another solution architect comes in, and then basically they do not have any history unless this thing is documented. If this thing is documented, then they do not have any questions for me whatsoever. Then have a good code quality. So this is important. As we saw before, with a dirty code edition, I kind of managed to increase and decrease both of quality attributes, but without that, it was kind of hard, to be honest. So that's why having a good code quality is important for each and every project. What about Spryker projects? This is a good question. Does it mean that it makes sense for a project to increase one quality attribute and decrease all other quality attributes? Probably it's not really possible, but still. Or does it make sense for a product to keep a balance among all the quality attributes? I do not know, because it really depends on your specific project and on your specific project needs. What is important to identify what quality attributes are important for your project. And then if you raise these concerns of with increasing performance to this level, we might decrease something else, and everybody's okay with that, then go with case one that we have here. Or if stakeholders are not okay with that, then propose another solution. Slightly increase performance, but slightly decrease all other quality attributes, or whatever dependency you might have there. And yeah, basically just make sure to notify everybody who's involved in the decision-making process. What about Spryker? Spryker, of course, we recommend to apply clean code, solid, keys, dry, Yagni, and everything else. So just check out our best and latest documentation that we have. Yeah, basically it will increase your supportability and extensibility and costs and other quality attributes already by design. And then here I have on the right side a nice picture. It actually is gonna decrease the amount of VTF, I hope you know what it means, per minute during the code review. That's actually it. And then recap what we have learned today, that increase of one quality attribute may increase other quality attributes, or increase of one quality attribute may have no influence whatsoever on other quality attributes, or decrease of one quality attribute might decrease some other quality attributes. And define quality attributes that are important for your project, check dependencies, notify everybody about those dependencies during any stage of your project development, keep track of decisions, including pros and cons of each and every decision, and have a good code quality. Tooling. Out of the box, we have already PHP Stun, Architecture Code Sniffer, and other stuff. So just check out what we have. And then if you see that that's not enough, just install additionally your static code checker or whatever you need to keep the code quality. Let me see. Yeah, and those are already included in the demo shops as well. Check tools, configuration, and rule set, because something that we have out of the box, it's still something that we have for demo shops and out of the box. Check the configuration and rule sets to make sure that they fit in your specific project and project development and basically your internal rules in your company. Feel free to change them. Yeah, that's totally fine. And yeah, propose as a new tool if you find something interesting. And actually something interesting stuff. So during this research, I was trying to use GPT, probably as everybody else is trying to play around with it. And I was asking exactly the same question. So just calculate me this specific formula. It's actually this Microsoft formula to calculate the maintainability index. And I was just clicking regenerate the response, and I was getting 66, I was getting 91, I was getting 68, I was getting 92, 65, and this is probably the most interesting one because it gave me 112, but because the maintainability index calculation from Microsoft cannot be higher, therefore it gave me the highest amount of points because it calculated it wrong. So what does it mean? It means that our job is still secure, at least for now, and it cannot take over the stuff that I'm doing. And that's actually it. Do you have any questions?